All right, so I'm writing a book about software design. And I think that this is a term that is thrown around pretty loosely in the industry, right? We say it a lot, and we define it very seldomly, right? I think that we have this sort of general notion of what it is, right? It's like a thing that we do when you write design docs at the very least, and it's a thing that we do more as we get more senior, right? It's sort of the hallmark of being an expert programmer is being able to come up with good designs, but like what is or is not software design, right? Is everything we do in the course of a day software design? And if not, like where do we draw that line? And this is not, I think, an easy question to answer, but a good place to start is trying to define what design is. And the best definition that I'm familiar with comes from Christopher Alexander, who says that every design problem begins with an effort to achieve fitness between two entities, the form in question and its context. The form is the solution to the problem. The context defines the problem. So for our purposes, right, we are trying to judge how well designed our software is, and we're considering two things, our code and the context around that code. But what are the contexts, right? An obvious answer are the users, right? This is arguably the sort of ultimate measure whether or not our software is any good, is whether or not it empowers users, whether they find it easy to understand. But I think a lot of development kind of happens over the horizon from the users, right? We're many layers of indirection from them. And so it's hard to use the user's perspective as a sort of way to shape our design decisions. So we tend to focus on something a little bit closer to home, which is to say the other nearby software, right? So these are both good and useful contexts to consider, but they are by no means the only ones that we do, right? When we're writing software in an industry setting, there's going to be a lot of weird little idiosyncrasies about our company, about our project. And these also go into the decisions that we make, right? Just to name a few possibilities, there's organizational structure, there's available headcount, there's individual expertise on our team, there's cost considerations, there's pre-existing infrastructure that we either can or must use, right? All of these are just as central to the designs that we are creating, right? And they are just as important in terms of how we're judged by what we deliver, right? Oftentimes, these sort of idiosyncratic considerations are at least as important as whether or not the users find the software easy to understand. And this is a problem, right? Because the first two of these contexts generalize pretty well, right? Pretty much every software project is going to have users, it's going to have other adjacent software, but this last kind of grab bag doesn't, right? Even trying to enumerate all these possible considerations would probably be like the work of a lifetime, right? And so I think what the result of that is a lot of software design literature sort of focuses on the parts that do generalize and then have a big ol' asterisk kind of dangling off the end of it that says, there are some other things too, but you can probably figure it out. And that's a problem, right? This means that we do not have an actual descriptive model for software design, you know, as it is actually done in the world, as opposed to some sort of idealized thing as we wish it actually would be done, right? And so as we try to think about how to kind of bundle all these things up, something worth noting is that all of these views of the context are what in linguistics is called synchronic, or focus on a particular moment in time, right? We're taking our code base as it currently exists, and we're taking a snapshot of those contexts as they currently exist, and we're comparing them to each other. And this is perfectly reasonable, but software is not a static artifact, right? It is constantly being reshaped. And so we can also take a diachronic perspective. We can look at how is our software sort of changing over time. And in fact, what we can do is we can say, that's our context, right? I want to judge the code base against what we expect that code base may become, right? And the neat trick here is this does actually wrap up all the other things, right? Because our expectations for the future are shaped by all of these other forces, right? Both the needs of the user and the needs of the organization. And so this is actually a path towards a descriptive model if we can figure out how to talk about the possible futures of our code. And it's worth noting, right, if we talk about change and the future, that the sort of predominant philosophy of change in our industry, which is these sort of agile methodologies, do not like to talk about the future. The Agile Manifesto was written in response to the failures of these sort of earlier big design upfront methodologies. And they saw talking about the future as sort of a slippery slope, right? If you begin to acknowledge the future, before too long, we'll be writing big design documents again. So they focused on this sort of ever-present now, right? We don't talk about the future, we just prepare for change, whatever that may be. And the way that we prepare is by following these sorts of best practices that they espouse, right? We keep our code clean, we write our tests first. And the assertion was that if we do that, and we respond to change, then a design will just sort of appear, right? Bottom up, as if by magic. And, I have nothing against these sort of lowercase agile sort of methodologies, right? These have become sort of the norm in the industry for a good reason. But I do think that these sorts of stronger, capital A agile sort of perspectives are kind of weird. Like, I think maybe obviously wrong, right? Certainly, they don't reflect how we actually do design and write software, right? When we go and we create our software, we can always reshape it, but it has a form, right? And certain forms are going to be easier to create from wherever we are than others, right? And as we go and we make choices, we sort of close certain doors and leave others open, right? And this is absolutely something that we talk about, that we think about when we write software. We are in conversation with these futures, whether, sort of the signatories of the Agile Manifesto like it or not, right? So I want to do a textual analysis of software, right? And this is because, based on sort of prior reading that I had done, I had felt this sort of resonance with this idea of thinking about possible futures in certain things that I had read in like analytic philosophy and semiotics and some other sort of literary analysis. And, if nothing else, software is a text, right? That is a representation that we work with day in and day out. It's not a particularly normal text, right? It's what we would call a living text, right? It's never actually complete. It's only eventually abandoned. It's a collaborative text, right? We are working with multiple people towards some sort of shared end. It's what's typically referred to as a hypertext, right? There is no well-defined order in which it's read. And, these are all fairly unusual and together extremely unusual, but it's not unprecedented, right? There are other texts, there are other books out there that talk about these sorts of texts. And so my expectation when I started my project, this book, I thought that I would find someone somewhere had analyzed software as a text, right? There are a lot of people out there who do it. Software is a pretty important thing in society, so surely someone had done my work for me. And I found that there was a field called software studies, which is largely populated by people who are in the literature departments at their universities. And so I thought, great, I'll start here. And I spent about a month reading pretty much all of the software studies literature. And what I found was odd. So these are 3 quotes that are in a book called The Interface Effect, which was written back in 2012. And it's pretty representative, right? It's a highly cited book. And these quotes are sort of built up to over the course of 2 pages. And Alexander Galloway, the author, begins with, "Code is the only language that is executable." And, I don't know, like arguably the recipes in a cookbook are also executable, but maybe he means like unambiguously executable, right? So we'll give him a pass, right? He then says, code is machinic first and linguistic second, right? So now he's doubling down. He's saying not only is code executable, but that's the most important part of it, right? The linguistic quality is, not as important. And then finally, he reaches the apex and he says, code essentially has no other reason for being than instructing some machine in how to act, which is, wrong, right? I mean, code is, among other things, a repository of institutional knowledge, right? It's a stepping stone to the other software that we're going to build using it, right? It's a way of learning about sort of software practices in general, right? It's many things. I mean, if Galloway were talking about like compiled, artifacts, right? I would be on board with this, right? Those are, kind of linguistic. Sure, there's a language that the CPU is trying to go and decode, but like he's not talking about that. He's talking about the thing that we write for a living, which is like high-level languages, and he is saying really all that matters about it is that it has a button on it that says go. And so I am not able to talk to you about a single paper here or a single book, much to my chagrin. So like I have over the past year been reading a lot of stuff that is not about software, searching for things that resonate with my sense of what software is. And I have sort of taken them where I've found them, and I've tried to sort of stitch them all together. And as a result, this talk is going to be pretty far-ranging. It's also going to be a little discontinuous because the original outline for this talk would have taken about 3 times as long. So I don't have the time to provide all the sort of context or kind of the connective tissue necessarily, but I hope that it will still all sort of make sense and ring true. So where I want to start is with interfaces, because interfaces are the longest lasting part of our code, and I think that this is easily demonstrated by 2 closely related thought experiments. The first is the grandfather's axe, right? My grandfather had an axe, he replaced the handle, he replaced the blade. Is it the same axe? And I don't know, but one thing that is preserved is the interface between those 2 things, right? Even if the handle is completely different, even if the blade is completely different, even if it's completely unrecognizable as the previous axe, there is some part that is preserved, right? And then the ship of Theseus is just like the maximalist version of this, right? Theseus goes on a journey. As he is sailing on a ship, he has to repair it 1 plank at a time. Eventually, all the planks have been replaced. Is it the same ship? Again, I don't know, but I do know what is still there from the original ship are the relationships between those boards, right? The interfaces between them. And, you know, what this means is that the smaller and more incremental our changes, the more the interfaces are preserved, right? And that is very much the trend in our industry, right? Our interfaces are becoming longer lived. And so to think about interfaces, I think the most useful sort of perspective is to look at the most common kind of interface, which is names, right? A name might point at a value, it might point at the implementation for a function or a class, right? And we can change those values, we can change those implementations, but the name remains the same. And, you know, I think that in our day jobs, we come up with a lot of names, probably more than any other profession in human history, right? And for some absolutely like bizarre reason, we do not talk about names very often. We do not look at the literature about names. We do not try to formally study them. And we ought to, but if we go and we you know, write code for some number of years, chances are we have a pretty well-developed intuition about names, right? And so I would like to go and poke at that intuition and kind of use that to draw sort of broader inferences about interfaces as a whole. So to begin with, let's say that we have these 2 values here, right? 2 variables close together in our code. They have different names, but they are assigned the same value. Is this an opportunity to get rid of some redundancy, right? Can we collapse these 2 variables down to 1? Who thinks we can do that? Literally nobody. Great. Yeah. So of course we can't, right? Because these might be the same value for different reasons. And at some point in the future, they might diverge. They might get different values, right? And if we go and we collapse them, we have lost a potentially meaningful distinction, right? And so this is effectively the point that a logician named Gottlob Frege made back in the late 19th century in a paper called On Sense and Reference. He created a similar example where he used the morning star and the evening star in ancient Greece, but I won't go into that. But what he was responding to was a you know, idea of names, which was just that like a name is a way of pointing at a referent, right? Pointing at some value. And, you know, Mill, who had sort of been the, you know, earlier sort of go-to expert on naming, would not have just said, collapse the 2 variables down to 1. He would have said, get rid of the variables altogether. Just sprinkle 42s everywhere in the code, right? And again, like, you know, this is something where you hear that and you kind of cringe because you have this intuition for, like, what is in a name, right? Why do we have them? And so what Frege called this quality, this thing that differentiated these 2 variables, is he called it the sense of a name, also sometimes referred to as the meaning of a name. And a good informal way to think about it is the path that we take to the referent, right? Frege, in a different piece of writing, talked about a mountain peak that you could approach from the north and the south, right? And as you travel towards that mountain peak, it will take on the sort of flavor of everything you pass through, right? The climate, the culture, the cuisine, right? Such that two people who arrive at the same point will have completely different sort of meanings in their mind, different connotations, right? They will be thinking of different journeys, even though they, both exist at the same sort of point at the very end of their journey, right? And then more formally, a way to think of the sense is that it's a predicate, right? It's a way of describing the set of things that it could possibly be pointing at. And so this is a useful way to think of an interface, right? An interface has a sense, and that sense describes what sort of implementations can sit behind it, right? And as these interfaces last into the future of our code, they constrain that space, right? They give us some handle on what is likely or possible in the future. But we have to go and complicate this a little bit more. So about 60 years later, Wittgenstein wrote in a book called Philosophical Investigations about the biblical figure Moses. And he pointed out that if you consider the meaning of what it is to be Moses, and we start to go and try to test actual historical figures to see, were they Moses? We are not necessarily going through all the things that are true about Moses, which are like, he was named Moses, he was born in ancient Egypt, he led the Israelites out of Egypt, he, came down with the tablets from Mount Sinai, and these are just like, the high points. He's a pretty major figure in the Old Testament. What Wittgenstein pointed out is that we can go and we can probably throw a lot of these overboard and still reasonably refer to as this historical figure as Moses. In fact, either of these things being true, right? Either leading the Israelites out of Egypt or coming down with the 10 Commandments, right? That probably makes someone a Moses, right? In fact, there might be multiple historical Moseses, depending on how specific we really want to get about it. But it's not just that anything qualifies. In fact, someone who just was named Moses, lived in ancient Egypt, and did nothing else of note is not a Moses, right? Not our Moses. And so what Wittgenstein is pointing out is that when you think about the internals of this predicate, right, we can't just think of it as a series of tests of necessary qualities, right? We're not just going down the line saying, was he named Moses? Was he in ancient Egypt? Was he fished out of the river by Pharaoh's daughter? And if any of these things are false, we had a short circuit and be like, nope, not a Moses, right? That is empirically not how we are thinking about meaning. What it is something closer to the second function here, right? Which I should note is not something that Wittgenstein talked about. This is sort of my attempt at, translating. But what we have is we have these sorts of two pieces, which we have this sort of inner function, which gives us a score on how similar to Moses is this person. And then we are going and testing against some threshold, right? And each of these two pieces, I think, are important in different ways, right? The first part, right, the fact that we have this kind of sense of the intensity of similarity to Moses means that we not only can identify who is and isn't Moses, we also have a total ordering, right? Anything that we know the meaning of, we can go and say this is more that than this other thing, right? And if we want to go and talk about the internals of this function, it's difficult, right? So the concept of similarity is very foundational to language, and it's hard to use a language to analyze itself. It's kind of like trying to bite your own teeth. And so, Wittgenstein talks about this more in Philosophical Investigations if you're interested, but it's kind of beyond the scope of this talk. The second part is also interesting, right? One thing about it is that it is actually easier for us to discuss, right? If I feel like I'm talking to somebody about Moses and we're talking past each other, like it's hard for us to discuss our own internal sense of what it means to be Moses. But I can at any point say, no, I mean all the way down the line biblical Moses, right? I can go and I can talk about the intensity of the meaning, even if it's harder for me to go and talk about the meaning itself. And so this is useful, but I think the far more relevant thing for us, for software people, is that when we're thinking about our interfaces, right, the specificity of them, right, the sort of threshold that they have to clear is almost always increasing over time. And this is for a few different reasons, right? One of them is what is typically referred to as Hiram's law, which is if you have an interface and people are using it, they will begin to rely on properties of that implementation, whether or not it is part of the contract offered by that interface, right? And so the general consequence of this is that we don't want to break our users' code, so this thing that was an incidental implementation detail becomes an essential quality of our code, right? But I don't think that this is actually the major driver. What I think the major driver is that our understanding of what a thing is includes what we expect it to become, right? So if we are going and trying to represent a real-world thing, our initial prototype will probably only capture a handful of facets about it, right? Our users will begin life as just an email address. But we also have other things that we know that we will soon have to add, right? We're going to have to add a physical address and payment information and all this other sort of stuff, right? And that might not be in the code, but it is in our understanding of that interface and what the implementations behind it are likely to become, right? And for non-representational things, I think there's a similar sort of property where we go and we compare it to more mature versions of that interface, right? If we're writing a key value store, we might begin with just a simple point query, right? Key to value. But there are other more mature key value stores out there. We can look to Cassandra, to Redis, for examples of things that other people have found useful, and those become part of our sort of possible future. And so when we're looking at a code review process and why someone might say, I don't think this quite works, there are kind of two reasons. One is that the implementation as it is simply doesn't clear the threshold, right? There is some sort of fundamental misunderstanding of what this has to be today, right? And ideally, this is something that we would catch with tests, right? There are certain essential properties that have been promoted to being essential, and we hopefully have tests that sort of capture that. But then there's another kind which is a little bit more amorphous, which is, yes, okay, this works for now, but I think it won't for very long, right? I can go and I can sort of twist this threshold to the right. I can raise it up and sort of think about, at some point in the future, am I going to have to go and fix this, right? And this might be, hey, you sort of took away the certain degree of freedom I think we're going to need. Or, hey, you have an ON squared solution here, and as we scale, that's going to become too slow, right? There are many sorts of ways we can talk about this, and none of them are, this sort of immediate glaring issue. It's not a functional problem. It's something that has to do with, how can we go and make our lives easier down the road, right? And there's a reason, I think, that we often have the most experienced members of the team doing code review, right? It's because they have often the clearest understanding of what the future, sort of holds, right? What it is that we need to plan for. Relatedly, I think that this can go and help us reason a little bit about two ends of a spectrum when it comes to trying to make a change in our code. On the one hand, we have this sort of highly disruptive change where we go and we make a change, but then it breaks something next to it, and then we try to fix that, and then that cascades out and out and out, and all of a sudden we have this sort of PR from hell, right? And this is because we've gone and we've changed the shape of that meaning, right? We have broken assumptions that existed elsewhere in our code, and our attempts to fix that break still further assumptions elsewhere in that code. But then on the other hand, we have, the good PR. We have something where someone asks us to do something, and it's like the code was anticipating it, right? We're just sort of pushing it a little bit further down this road that stretches out in front of us. And so, this is, for me at least, what I associate with good design, right? It's really pleasing when I go and try to add something, and I find, oh, it's like someone anticipated this. It's like I anticipated this without realizing it, right? And so, this is, I think, what we want, right? We want to maximize the amount of time we spend at that end of the spectrum. And so the forward march of time, the continuous development of our code base is not just this sort of Hiram's law calcification where we accumulate cruft. Like, it is that, but not just that, right? We want to as much as possible, go and simply have our software become more like itself, right? And so to do that, we need to have everyone have a largely consistent view of what are the paths ahead of us, right? For everyone to kind of paint within the lines, there needs to be a shared understanding of what those lines are. And so the rest of the talk will be basically focusing on well, how do we do that, right? And I think that a really important sort of framework to think about this is what is typically referred to as the principle of least surprise. Which, if you apply it to, say, user interface design, says when the user performs an action, whatever happens ought to be the least surprising thing. right? And that surprise is shaped by the user's expectations, and those expectations are in part due to our software, right? We should be consistent. If it does one thing on one screen, it should do much the same thing on another screen, but there are other expectations that come from the larger ecosystem of software, right? And there is a concept in statistical mechanics called surprisal, which is basically the measure of information, of entropy, in a piece of data. And the important thing about surprisal is that it points out that that surprise is not intrinsic to the data. Surprise comes from a mismatch between some predictive model, right, our expectations, and some data. You can have an arbitrarily large data set, and as long as the person receiving it expected exactly that data set, there is no entropy, right? There is no information being actually conveyed. And so we want to minimize surprise, right? And I think that this sort of framework gives an answer to, or at least a potential answer to this question I posed before, which is what is and isn't software design, right? Given that we want to go and minimize the surprise of someone going and trying to read our code, there are sort of two things we can do. We can set expectations, or we can write code that conforms to the existing expectations, right? And in the sort of earlier big design up front, what we would do is spend a bunch of time setting very particular expectations, and then we would finally go and sort of act upon those expectations. But that's not what we do really anymore. And so it's possible to go the other way, right? We can have a bunch of pre-existing code, and we can create a model for why it makes sense, why the choices that were made in the past are retroactively unsurprising, right? And I think this is something that we often do. I think, again, this is something that more senior members are often trying to go and make sense of what is already there, to explain it such that the next person who has to go through it finds it unsurprising. And so there's a feedback loop, right? We're constantly switching between these two things. But again, this talk is about software design, and so I want to focus specifically on that. How do we set expectations? And the way that we're going to do that is using a field of kind of literary analysis called structuralism that sort of reached its peak in the mid-20th century. It builds upon ideas from Ferdinand de Saussure's course in general linguistics, which is one of the sort of earliest seminal texts in semiotics. The label sort of structuralist was thrown around pretty loosely. There's a lot of people who use it for a lot of different things, but I think that for our purposes, it is a useful tool for talking about possibility and expectation. I think most of you are familiar with the hero's journey, right? This kind of very archetypal, generative grammar, basically, for this particular plot that shows up over and over and over again because it has this sort of like mythopoetic resonance within the human mind. And this is a structuralist text, maybe one of the best known. But there are also sort of slightly smaller bore attempts. One that I like is by this guy Todorov, who wrote the typology of detective fiction. And so the original structure, the one put forward by Saussure, was language. His structure was language, and he said that language is basically a graph where the words are vertices, and the edges are connecting each word to highly similar and highly dissimilar words. And the point that he makes is that when a word comes into existence, it does not emerge full-fledged with a dictionary definition tacked onto it, right? It begins life as a bare label, and then the meaning accrues from the words that are next to it, right? The words that are similar sort of add to the meaning. The words that are dissimilar chip away at that meaning. And finally, we have this thing, which is the sense of that word, which we then try to approximate with a dictionary definition. And so I want to talk about a particular structure, which is the structure of a murder mystery. And so there are two different structures here which are interrelated. The first is the trace, which is the sequence of events that are in the story, right? We begin with some number of events that might have motivated a murder. Then we have the murder. Then we have a series of interviews with all the suspects. And then finally, the detective reveals whodunit, right? And I want to emphasize that this is not some sort of like regular expression that validates whether something is or is not a murder mystery, right? We can go and we can sort of work outside of this formula, right? We can deviate from it, we can elaborate upon it, right? But what this structure does is it provides a baseline such that the only thing being communicated are these deviations and these elaborations, right? And then the trace, as these events occur, right, what they're doing is they're updating the state, which is shown above as the characters or roles and their properties and their relationships, right? And since the state is derived from the trace, right, it's tempting to say that the trace is the only thing that really matters, right? That this is the primary source of information, and this is certainly the perspective that's taken by the structuralists, and it's also the perspective that was taken by, Kafka, right? We should focus on the events that construct the state rather than the state itself. But I think it's worth asking. Let's say that you are sitting down to watch a TV show and you're like deep into it, right? 3rd, 4th season, and a friend sits down next to you and says, "Catch me up." What do you tell them, right? Do you start from the first episode of the first season and then begin to recount every word that was said, everything that happened? Well, no, right? What you'll do is you'll generally describe what this state of the world is now, plus maybe a handful of events that are like just recently happened, right? And the reason that we're able to do that is because stories are made up of narrative arcs, right? And narrative arcs have the general structure of some equilibrium, a disruption, and then a new equilibrium, right? And once that arc is complete, we don't really care about all the events that occurred within it. We can focus safely on just what is the new equilibrium, right? So what we're describing to our friend is the state as of the most recent equilibrium plus the events of any narrative arc which is still in flight, right? And so let's think about debugging for a second. We are perpetually the friend sitting down and asking to be caught up. Right? We don't set a breakpoint at the entry point to the main function. We set a breakpoint where we care about what's going on, and generally speaking, there have been several billion events that preceded that breakpoint. And so how are we able to make sense of this at all? Well, the answer is that we have created our own narrative arcs, right? A very important one are pure functions, right? This is what referential transparency means. We can go and we can replace the invocation of a pure function with its return value, right? We can also do this for less pure functions, right? In general, if we go and call a service or read something from disk, right? As long as there's not an error, we can just focus on what was returned rather than all the things that went into doing it. But in more complicated cases where you want to think about failure, there's also like database transactions or protocols, right? TCP allows us to forget about all the packets that might have perished on their way to giving us some piece of information, right? We can just focus on what it was that we received. And I think that this gives us a little bit of insight potentially into why debuggers haven't supplanted printline debugging. Because what printline debugging allows us to do is to create our own narrative arcs, right? Our own sort of abstractions over the trace. We can say, oh, we're entering this scope, or we're exiting that scope. And we can have many layers of abstractions within that, and then they all sort of spool out in front of us, right? Where you can read through them like they're a story. And it's very flexible. It's very, whatever sort of works for us, right? And what a debugger does is it lets us get a very clear understanding of what the state of things is at some moment. But once we're there, all we can do is just get dragged down to this sort of lowest level abstraction and just step through it. And sometimes that's useful, but ultimately, I think most of the time, that's not what we need. What we want is a high-level summary of the story so far. So I want to do a textual analysis, and I have these two structures, right? The state and the trace. Which of the two things is sort of, most represented in the text of our program, right? According to Dijkstra, in go-to statement considered harmful, we should do our utmost to make the correspondence between the program spread out in text space and the process spread out in time as trivial as possible, right? So here he's saying we shouldn't use go-to statements. The sort of consequence of what he said and like what others were arguing for is that we adopted what was called structured programming, which is to say that, yeah, we do actually have a forward progression through the code unless we have certain special control flow operators like if statements or loops or other things like that. And that's good. We should do that, right? But if we go and sort of apply this logic to other things in modern programming languages, like what else would this criteria consider harmful, right? If one function calls another function, right, we're going merrily through our text linearly, and then all of a sudden we jump to some other part of our code base. Like, is that bad? If we have multiple dispatch and we go and we call some sort of abstract method, we don't know where the trace is going to end up, right? It depends on what the object is that we're invoking, right? Is that bad? And let's not even get into how we can go and try to serialize multiple threads or multiple processes into a single coherent trace, right? These are all things which, like, we do in modern programming languages, in our sort of day-to-day thing, right? These are things which go and make the trace very indirectly represented in our program's text. And so I think it's uncontroversial to say that, generally speaking, in our code, we are trying to represent the state, right? Certain patterns within the state, how we represent data within memory, right? That is sort of what the text of our code most directly represents. And so let's look at the state of our murder mystery, right? At the outset, right, we have this structure, and each of the vertices are here, and each of these vertices has an associated sense, right? The sort of person who might be a victim, the sort of person who might be a suspect. And you'd think that the sense of who is a detective might be kind of narrow, but it isn't, right? Often the joke is that it's a little bit incongruous who's a detective, right? You have Agatha Christie's Miss Marple or G.K. Chesterton's Father Brown, right? You have some elderly woman or some Catholic priest, and they just like happen to come across dead bodies really often, right? But like also the victims and the suspects, like these are pretty broad. Like, who is a victim? Well, someone who someone else wants to kill, right? And so we don't get a lot of shape from this if we are ourselves trying to write a murder mystery. But it's worth noting that the moment that we begin to fill in any one part of the structure, right, the other connected parts of the structure begin to narrow as well, right, because these edges are mutually constraining. And I think a useful way to kind of think about this is a much simpler structure, which is a sentence, right? Let's say that we have a few gaps in the sentence we want to fill in, right? There's clearly a relationship between all these different words, right? Whatever's on the left needs to be able to jump over the brown thing on the right. And so the first choice we make here is going to be the most open-ended, and everything else is going to be incrementally narrower, right? And depending on what we choose, we might, shrink our options down to a singleton set, right? So where we make our first decision when creating a design matters a lot, right? And in a sentence, maybe it doesn't matter, right? We can kind of hold the whole thing in our head. We can play it backwards and forwards. But if we're dealing with a larger text, a murder mystery, say, or our code, it matters a great deal more, right? We can't fit it in our head. So where should we start with a murder mystery, right? As I said, the relationship between the detective and the other people is a little bit loose because almost anyone can be a detective, right? And if Miss Marple spends a lot of time in England, we can always just send her on vacation if we want her to solve a crime somewhere else. But there is a very strong connection between the suspects and the victims, right? Whoever we choose for one begins to constrain the other, and the victim sits at the nexus of all these strong edges. And so I think it's clear that this is where we begin, right? This is the one decision that gives maximal shape to the rest of the structure. This is the center of our structure. So with that in mind, I want to talk about a different structure, one that you're probably more familiar with, which is the venerable model view controller, right? And when this is explained, it's often kind of explained as this sort of broadly trace-like partitioning, right? The request comes in to the controller, the response goes out of the view, somewhere in between, we do some stuff with the model. But I don't think that that's why this is useful. Why I think this is useful is that the model is a superlative center, right? What we put in the model gives a lot of shape to what we find elsewhere in the code base. And this is why Rails is able to do this sort of auto-scaffolding, right? Once we go and say, hey, there's an entity, it has these fields, it says, great, check out what I put for you in the controllers and in the view, right? And again, these are not mandatory. You can go and you can edit the scaffolding, right? But these minimize the surprise there, right? They give this structure to this where not only when we're writing do we have all of our sort of work sort of laid out in front of us. When we're reading, we know that we can look in the model and get a pretty clear understanding of what the rest of the code base looks like. And so the model is a very useful center, but it also contains its own structure, right? Typically sort of shown as like an entity relationship diagram. And here we have a very simple one, a student, teacher, janitor, class, classroom, right? So what's the center here, right? What's the center of our database schema? Well, I would argue that it's typically the user, right? And notice here that we've gone from sort of undirected edges to directed edges, right? Because in a relational database, there are no directions to those relationships, but once we put it in memory, right, references point somewhere. And objects contain other objects, and typically it is our user that contains all the other things. And so this provides a sort of path through them, right? If the student is a user, then we pass through the student to reach the class in the classroom. We take on the perspective of the student when thinking of the class in the classroom. And so when we think about what is a classroom, we say, oh, well, a classroom is where a student attends a class, right? What do we need to know about it? Well, we need to know its location so they can get there, right? But if we think, what if the teacher's a user? Well, now a classroom is where a class is taught, right? We don't only need to know what the location is, we also need to know its capacity. We also might need to know what's its AV setup, right? How many students can I teach? How can I teach them? And it's worth noting that when we write our MVP-like prototype of this, it's likely that we won't go and try to come with a database schema for the AV setup, right? That sounds hard. I don't even know what the taxonomy for that would look like. But it's going to be in our head, right? Where it's going to be part of our sort of teacher view of a classroom, right? That becomes part of its sense, part of the meaning of that interface, even if it's not directly represented in our code. So structures exist to minimize surprise, right? And the way that they do that is that they have strong constraints and obvious centers so that we can all start in largely the same place, right? And have a largely sort of consonant understanding of what we can expect elsewhere. And these vertices may contain and constrain other substructures, right? The fact that all the things in our model are part of that model, that gives them a certain sort of flavor, right? A certain sort of shared meaning. And so with all that said, I want to move to what I think is a necessary consequence of everything that I've said so far. So top-down development was basically the bad old big design up front, right? We begin with the master design document. But of course, that leaves a little bit unspecified, so we write a bunch of sub-documents for each of the components, right? And back in the 70s and early 80s when this was sort of the ascendant thing, right? These documents would have full-on flow charts for what the code should do, right? And when you finally reach the end where the code is actually written, that was treated as the least interesting part. You're basically compiling the design document down to code, right? But we don't do that anymore for obvious reasons. But when we put aside the top-down, the obvious sort of retort to that was, bottom-up, right? We just start writing code and the sort of, design sort of blossoms up around it. But bottom-up, as it is currently described, asserts essentially that it doesn't matter where we begin, right? Sure, we could go and we could start with a model, but we could also start with a view, or we could start with some, util code or something like that. And the assertion is that the result will be the same, right? We'll arrive in the same place. And I don't think that this is true, right? This is not descriptive of how people actually write code. People don't just start anywhere. People start with the center. They start with the model. And so I assert that anytime we are talking about bottom-up development and we're actually getting stuff done, it's because we are working within these structures and we're not fully defining them at every level. We are descending through this sort of central spine, right? And then we finally land where we write some code. And then through this sort of surprise minimization, right, which is, again, going back and forth between reshaping the design, reshaping the code, we are going and sort of filling out the rest. And I think that this is, again, a perfectly reasonable description of what people do to be successful in our industry. And I think it's a perfectly reasonable strategy to do that. But we don't talk about it that way, right? Oftentimes people will go and say, no, 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 I'm not doing any sort of explicit design. And I would argue that in those cases is largely because they're unaware of it, right? If you spent your entire career writing CRUD MVC web apps, that's like the water that you swim in. It might have become invisible to you, but that doesn't mean that it doesn't exist. So I've talked about structures, and I think that these are valuable because structures are a fungible expertise. right? This is a sort of knowledge that we can carry between jobs, right? And clearly, such knowledge exists, right? When we're hiring someone who has like 5+ years of experience, we don't sweat whether or not they know the particular language or the particular framework that we're using, right? We assume that they will pick it up, quickly enough, right? And part of the reason that they are able to do that, part of the reason that they are able to go and get up to speed so quickly is because they know where to look first, right? The one thing they can read that will give them the maximal information. And, I think that structures don't need to be taught, right? I'm pretty sure that none of you here today have ever had someone show you a diagram of a murder mystery, but you kind of know how they work, right? We're good at this. We're good at coming up with these sorts of patterns in our head and thinking about how all the pieces relate to each other. But it doesn't have to be that way, right? We could talk about these things. We could actually go and try to, talk about what these structures are, and we could, give names to them, and we could create a shared vocabulary, a shared literacy for talking about them. And I think that that's, something that's worth doing and something that I want to explore in my book. So that's it. I'm just almost completely out of time, so please do catch me when the talk is over. But also I'll just say, to everybody in the audience, to anybody watching this video, like, I have been spending an awfully long time in the wilderness here, trying to draw connections between things that have not been connected before. And this talk was a little bit harrowing for me because I genuinely don't know what other people will think, right? I've kind of convinced myself, but I don't know if other people are convinced. And so if you are not indifferent to what I've said here, right? If you like it, if you hate it, I genuinely would value your feedback. So, here today, at the rest of the conference, over email, whatever else, please do drop me a line. Thank you.